Good morning to you and welcome to the Engineer Construction Lecture Hub. Today we'll talk about slab design. As you know, we have slab is basically what provides is that structural component that gives that platform, in a building. All right, it gives that wide surface area in our building. Now, slabs, we have different types of slabs. We have the solid slab. We have the solid. We have the solid slab. We have the waffle slab. We have the rib slab. We have the flat slab. Now these are different types of slabs. Okay, these are types of slab. Now the solid slab is the one that is predominantly found in our structures. Okay, that's solid slab. Then the waffle slab are those slabs that have an inward form of indentation. Okay, where you have shapes like this. Okay, in your slab, maybe this is your slab now. This is your slab. You have something like this. Okay. Now these are projections, inward projections. Okay, these are inward projections. So this is like your slab. These are inward projection, and when you have this, is what we refer to as your waffle slab. Now your rib slab are those ones you use blocks. Okay, use blocks. Then at this center we have our ribs, cutting across our ribs. Now also remember, our waffle slab also have ribs as well. Okay, but the ribs are they are not as big as that of the rib slab. So the both of them, the waffle and the rib slab, they are of the same types of slab, but it's just that the materials or the orientation at which that slab is being constructed, that is what differentiates between the waffle slab and the rib slab. Now the flat slab is that slabs that rests directly. Okay, that rests directly on a column. Okay, that rests directly on a column. Okay, now this is a slab. This is a slab. Remember, in our solid slab, in this solid slab now, you discover that this slab is being hinged. Is being hinged to beam. Okay, if this is a one-way spanning slab, is hinged to a beam. Okay, two-way spanning slab is restrained at the four sides. Are you getting me? So that is for flat slab. Now flat slab, there is always what we refer to as the stresses here. The stresses in this region is very high. Okay, because in our solid slab, you discover that the columns are being hinged, or rather the beams are hinged to the columns. Okay, before you now have the slab on it. Okay, it's quite different from that of the flat slab. The flat slab now, column have direct contact with the slab. Okay, so that is the difference. All right, in these various types of slab. Okay, so but our emphasis here is on solid slab. Is on solid slab. Okay, now there are considerations. Okay, there are considerations we have to look at when we want to design our slab. Now, first and foremost, we have to look at the loading of the slab. Okay, the loading of the slab. We have to look at the span. We have to look at the depth of the slab. Okay, we have to look at also now these are considerations we'll look at. Now the loading aspect has to do with how the load, okay, the load is being applied to that slab. Okay, for example, if you have a simply supported slab here, we have a uniformly distributed load as W. We have our span here. Okay, so this loading system, we also have this. We also have this in this way. Okay, now this is a uniformly distributed load, while this is a point load. Okay, this is a point load. This is a point load. This is a uniformly distributed load, but they are all simply supported slabs. Okay, so we have to also look at that. We have to also look at the spanning condition. The spanning condition. The spanning condition, the span condition has to do with if that slab is, if it's a one-way spanning slab or a two-way spanning slab. Okay, we have to look at that. Now there are conditions that we use to judge if that slab is a one-way spanning slab or a two-way spanning slab. If, for example, we have our slab in this format, okay, or rather, let me start with this. Let me start in this format. We have our slab like this, okay. We have here as 8 meters, okay. We have here as 2 meters. Are you getting me? Now there is a ratio. It's called Ly over Lx. Okay, Ly over Lx. Ly is the longer span, Lx is the shorter span. Okay, so in this case, okay, for us to find out the Ls, the condition of this slab, we now have 8 divided by 2, which is 4. Okay, now you remember, or have it in mind that your Lx, if it's greater than 2, it means that it is a one-way spanning slab. So please take note of that. Okay, if Lx over Ly over Lx is greater than 2, consider that slab as a one-way spanning slab. But if peradventure you have something like this, where you have 3 meters, you have 2 meters. Okay, so automatically this will be 1.5. Okay, now you see that this 1.5 is less than 2. Now once your Ly Lx is less than 2, in this case now this becomes a two-way spanning slab. Okay, so this is a ratio that you can use to assess and to determine the boundaries in terms of the type of slab, either a one-way spanning slab or a two-way spanning slab. So take note of that. Okay, now in a one-way spanning slab now, in a one-way spanning slab, for example, you have it this way, okay? You have it this way, you have 8 meters, you have 2 meters. So what it means now is your main reinforcement should run across this, while your distribution runs across this. Now, in this regard, your main bar will be designed, okay? Your main bar will be designed, while the distribution can be provided, okay, as nominal steel bars, okay, it can be provided, all right? But in the case of this, where we have 2 meters, 3 meters, and we consider it as a two-way spanning slab, it means that